He has chosen these voltages 2/3 or 1/3. As a result, we got this relation. If you choose some other values, you get some other value. I am sure you have chosen it to make this almost equal to RC. So, you can choose your value of resistor capacitor connected externally to give you the appropriate amount of time delay. So, this is the 555. So, with this we have now completed the following till now. We studied how to do analog signal processing, in the sense, given a waveform, how do I make the amplitude of the waveform larger by amplification, and the type of amplifier you use for that purpose appropriately chosen with feedback to make the amplifier compatible with the source and the load. If the source is, that is, a transducer is a low impedance transducer, we would like input impedance also to be small, and if you want output impedance to be large, we choose a particular feedback structure which will have low input impedance and large output impedance. And so, depending upon the transducer that you are connecting to the amplifier and the load that you are connecting to the amplifier, depending upon the characteristics of that, I choose an appropriate amplifier configuration, either VCCS configuration, VCVS configuration or CCVS, which has a different input impedance and output impedance. And I can modify this input impedance, output impedances by choosing an appropriate feedback network. And advantage of feedback is I can increase the bandwidth, and of course we lose the gain, but I can get more gain if you put one more stage of that is not a problem. So, this advantage of feedback is to increase the bandwidth of that, ability to adjust the input impedance, output impedance to suit the requirements of transducer and the load, and so on and so forth. So, basically if you are given a signal and you want to amplify the signal, under conditions of given load and transducer, I know how to design the amplifier now by using the technique. If you have two signals and you want to add these two signals, addition, which is a mathematical operation, I know how to do it. T to T, at every T, the value of S1 and the value of S2 are added, right. So, that is what this summation of two waveforms mean, and we know by using an operator amplifier how to use some two signals. We also have found a way of finding difference between two signals by using a difference amplifier as a op-amp configuration or as a two transistor diff-amp topology. So, I know how to do a difference between two signals, I know how to do a addition of two signals, I know how to amplify a signal. I also would like to know how to multiply a signal, two signals, because that is also an important mathematical operation. So, I need to learn how to do multiplication. We have studied that also in the case of difference amplifier, where we said that we apply one signal to the change in the current source and other signal to the base of that, and approximately we will get a multiplication. However, the problem you should recognize is that in that configuration it will only work for one quadrant, because this current source will only change with respect to the signal in some direction. Similarly, the current will also change in the transistor also. So, generally what we require is a 4-quadrant multiplier, so that both input as two signals S1 and S2 lying all positive or positive negative, all quadrants have to be covered. So, there are separate multipliers for each quadrant designed and put into a single chip called a 4-quadrant multiplier. Each quadrant multiplier is basically a diff-amp. So, it contains a large number of diff-amps which cover each one or each pair one quadrant of the signal variation. So, this is called a 4-quadrant multiplier, but basically what you have here is a multiplication by using a DFAM, and that we have agreed in the, when we study DFAM, we can do that. The only problem we had was that this is a tan hyperbolic function came in the DFAM, and there is a simple way of converting this tan hyperbolic function to linear function by using a inverse inverse hyperbolic by using a simple diode. I have not mentioned that to you, but it is possible to do. So, people incorporate that also into the multiplier to make a linear relationship between the output equal to x1 into x2. So, this is what is called a Gilbert cell, as I mentioned to you, where in this tan hyperbolic inverse is also incorporated, called the Gilbert cell. So, we know how to do multiplication. Okay. There is another ways of doing multiplication, which simple algebra will tell you. If you have to x1 and x2, if I add this up and square it, and if I subtract this and square it, and add these two and subtract these two, I get a 4 times x1 x2. So, I can use this mathematics to make a multiplier, because I can add two signals that have to be squared up, right. So, the squaring up can be done by using a nonlinear device which has a square law characteristic, y is equal to x square, and typical square law characteristic is a diode. Diode has an exponential characteristic theoretically, but within some region that exponential can be approximated as a square law. So, people use this technique of taking a diode and operating only within a region where the curve is approximately equal to x square. So, you can do that, and this also I know, this also squaring also I know, and take these two and add up. This is another way of multiplying two signals, and people made hardware based on this principle for multiplication. Especially high frequency, this is what the technique we do for multiplication. So, the only operation, once I know how to do multiplication, how to do all this, then I can also find out the how to find average value of a time signal, right. So, you take the signal, put it in integrator, right, that will give you average value. Integrate we know, using an op amp, put a capacitor and resistor, get an integration. So, we know how to do integration, we also know how to do differentiation. So, this time dependent operations like integration, differentiation also I know how to do. So, if you want to find the average value of the signal, you simply integrate it and find out what is the average value. If you want to find out the RMS value or mean square value, you square the signal and integrate it. How do you square the signal? Same multiplier, you put the same signal on both terminals, so you get a square, right, and you put an integrator. So, I know how to do in hardware in integration, mean square value. Like this, all the operation that we talked about, mathematical operation to be done on a signal at any given point of time in your calculations can be represented equivalently by a hardware which will do this job for you. Of course, now we have a choice between doing this job in hardware or doing the job in software. Now, the question is, which one would you prefer? So, this is the decision you will have to make depending upon the problem, because a single operation on a computer will take certain amount of time. For example, if you want to multiply two numbers, I am sure you know better than me that you have to read one number from some memory, read another number from some memory, and take these two and multiply and then get the output, right. So, each one takes some amount of time, reading from memory and multiplication. So, there is some amount of time required to do this operation in a computer. Of course, the faster enough computer, this time will be less. In this, there is no time, right. As long as the bandwidth of this system is quite high, almost I get instantaneous answer to the problem, right. So now where speed is a consideration compared to speed that is there in the corresponding software, this may be a right way of doing it compared to the using a computer. So it is a decision you have to make. Today you cannot say whether this is the right method or that is the right method. And there were early days of computers where we said this is the right method of doing it. But as time has passed and computers become faster and faster and faster with more memory, more this, more that. So now it has become a competitive world. So it is for you to decide which role you will have to. But you must keep in mind very clearly that computer in general for a single operation takes comparatively more operations in terms of pulling out the number, pulling out another number, multiplication, addition, whatever you want to do. So that of course depends upon the speed of the computer. So this decision I cannot say right away whether you should do this or do that. This is a decision you have to make.